It's taken over 2 decades, thousands of international scientists, and billions of dollars to get to this monumental moment. The James Webb Space Telescope is finally ready for launch and could revolutionize our understanding of the universe.
I've been working on this project for 11 years. I have feelings of anticipation, worry, and also relief that we finally get to do what we've been practicing for years to do. It feels unreal, like it's not really happening.
Oh, it's real, and it should be launching in a matter of days, hopefully.
You have to build something as big as Webb to really get that capability to address some of these most fundamental questions we have.
Questions like, what did the first galaxies look like? How do stars and planets form? What are the key ingredients needed to support life on another planet? Webb has been in the works since the mid-90s, and today is an international collaboration between NASA, the European Space Agency, the Canadian Space Agency, and many other academic and industry partners. When it was first proposed, the telescope had one major goal: peer back 13.5 billion years to see the first galaxies. Light from those far-off galaxies has been stretched through our ever-expanding universe. By the time it reaches Webb's mirrors, it's stretched out of our visible light spectrum into the infrared region. So this is why Webb was designed to see infrared light.
Since then, the mission has broadened significantly scientifically. We now have 4 science themes: the first galaxies, galaxy evolution, the stellar life cycle, and other worlds.
That's a lot to tackle. So how exactly is Webb going to do all of this?
The James Webb Space Telescope will achieve these goals by 2 things. First, by being large, and second, by being cold.
So let's start there. If you haven't noticed, Webb has a massive, eye-catching gold mirror. It's made up of 18 smaller segments that will click into place after deployment and create a total surface area 6.5 meters across. For comparison, Hubble's primary mirror is only 2.5 meters in diameter.
You need this large mirror to be able to collect a lot of light. The more light you can collect, fainter objects you can see.
And remember, the temperature of Webb is also key. The telescope has to be kept really, really cold. That's because if a telescope is warm, it can emit its own infrared wavelengths and disrupt observations. So to keep Webb at a chilly 50 Kelvin, engineers designed a tennis court-sized sunshield to block out light and heat from the sun, Earth, and Moon. To do this, the shield is made up of 5 layers, which insulates the telescope while allowing heat to escape between each layer. Then there's the infrared instruments themselves, which allow the telescope to do 2 things: observe objects that emit longer, redder wavelengths like the earliest galaxies, and cut through the cosmic dust to see the nebula where stars and planets are forming. Using all this new and improved tech, Webb will be able to show us things we've never even seen before.
When you launch the telescope, it does all its science, it sends all this beautiful, enormous amounts of science data back, that you can do so many things. I mean, the amount of information that will be there is absolutely astounding.
So after countless hours of hard work, setbacks, and dedication, the James Webb Space Telescope is finally ready for liftoff. The telescope will blast off from ESA's spaceport in Kourou, French Guiana. The observatory will launch on the reliable Ariane 5 rocket, which is built to carry heavy payloads. Still, Webb's mirror will be folded to fit into the payload fairing. After liftoff, Webb will spend about 30 days traveling to the second Lagrange point, where the Webb telescope can comfortably stay on course with the Earth as it travels around the sun.
Watch the launch, then follow us for about 6 months as we get everything ready. And please have patience during this time. It is really necessary to take 6 months to get everything cold enough, focused, everything checked out before you get to see all the beautiful images that we've all been waiting for.
And hopefully, we'll be surprised by what Webb discovers.
We can plan all day long the science that we're going to do, but potentially the most exciting discoveries we can't even imagine.
Just about as long as Webb has been in production, we've been covering it, or at least that's what it feels like. Take a look at the experts we've interviewed over the years if you want to know about how James Webb got to this very exciting moment. Don't forget to subscribe to Seeker. Thank you so much for watching, and I'll see you next time.